the approach that I will present try to overcome these limitations. So the first step I will use Bayesian net. Bayesian net are simply a compact representation of probability distribution. There are nothing more than compact representation of probability distributions. However, they are very useful, very intuitive to represent independence relations and causality relations. And they are represented in a very intuitive way because they use graphical structure comparing to logical-based approach to probabilistic. It's very simple. It's a DAG where variables are related with arcs, and the arcs expresses some influence or causality relations. For each node, we should specify conditional probability distribution given its parents. And in fact, I will use the simple form of Bayesian net. We have tested other form of Bayesian net like TAN or Forest Bayesian net, but it gives really similar results. So naive Bayes is a really simple form of Bayesian network. Variable, the main things is that there is exactly one hidden variable, which is called C to denote the class, hidden in the sense it's not observed, and all the leaves are observed variables. And the main assumption is that each variable in the context of its parent is independent of the other variable. So this is a strong assumption. It's well adapted for classifications. These variables here corresponds to the object, what has been observed, and C corresponds to the class. Yeah.
The A's are conditionally independent of each other based on the presence of C. Is that what you said?
I say that, for instance, A1 is independent of A2 if C is learned. And each variable is independent of the other variable in the context of parent. If you know the value of the parents, the two variables become independent. So let's see how we will model it. I will distinguish two kind of, there are two aims. First is intrusion objective prediction. This is what I said. I mean, it's to determine the set of alerts that allow to compromise some objective intrusions. And the second is alert filtering. However, I will use a very weak definition of attack plan. Because here I don't want to have some expert who provide the worst scenario. I don't want to have it, okay? I want to learn it automatically. Of course, I will not be able to provide the whole plan. I will also simply able to provide which actions are involved in this intrusion objective. So an attack plan is simply a set of actions with an objective intrusion, something that I would like to protect. It can be some secret file or some machine that I would like to protect. AEs are instance of actions represented by alert, and O, what is called an intrusion objective. The only thing is that I require that AI, each AI has some positive influence on the objective intrusions. One possible definition of positive influence means that the probability of O, of objective intrusion, if AI is null, increases if AI is not observed. I mean, if you observe AI, the probability that intrusive objective will be compromised will increase. This is what it means. So the goal is to model each intrusion objective with a naive Bayes. I use historical data, and then I will provide some analysis with respect to CART. There are three steps in our approach. Data pre-processing, I will try to explain them. constructing a naive base, it's not hard, and prediction. So recall, the input is a set of alert. It's exactly what intrusion detection suspect. When they suspect some malicious activity, it produces alert. Some action intrusion detection believes that some action have been executed. So malicious action have been executed. Our aim, of course, there may be different severity levels, and our aim is to see whether this reported alert is in fact a preparation to some severe attacks that will arrive later. This is exactly our aim. So the input is a set of alerts, nothing more. Each alert contains plenty of information. And in general, the input if you use, for instance, 3-month observation, if you use EDS on 3-month observation of some academic traffic, it corresponds to 1 million alerts. So it's the number of alerts is very, very huge. So this is one of the difficulties. So the alert, each alert has some format, but the set of alert it just as it arrives. And what we need is the output is a formatted data, something that can be used automatically. So we want to transform this set of alert to something that can be exploited, that can be used automatically for learning purpose. So maybe it's better to explain on the example rather than the algorithm. So there are different hosts. Hosts can be just a machine from which traffic allows, because alerts are produced by hosts. So what I write 1, 3, 3, etc. at the big, don't know where it is. Here means this is the first alert that arrived and is identified by number 1. It corresponds to some action number 1. Here means that the second arrived that is reported, and it corresponds to action number 3. Here means the third alert that is arrived, and it corresponds to action number 3, and so on. So the only thing that we have done is we sort the alert chronologically as they arrive. Then we define windows, time windows. Why we need to define time windows? Because it depends on intrusion objectives. We know, for instance, if one would like to, if one intend to use some DDoS attack, distributed DOS attacks, in general, we take, for instance, 2 hours. We are sure that if within 2 hours it didn't observe some important actions needed for DDoS, you can say that in these windows there is no DDoS attacks. It corresponds to the time needed to reach intrusion objectives. It depends on intrusion objectives. So this is for learning steps. For instance, the first one here. So we have observed some actions. This is for training. There is no reported. So we know in these windows there is no severe attack or intrusion objectives. So this is what we do. We took the set of alert as reported. Then we took windows of times. The windows is the time needed for the intruder to achieve his objective intrusion. For instance, for DDoS, usually it's 2 hours. Then we report, this is for the training. The report, what is in red, is the severe attacks or intrusion objective that we like to protect. Namely, there is some severe attack that has been reached, and we want to learn under which condition it's reached. So each time when some severe attacks has been reported, we move and we built a new windows. Why we built a new windows? Because all the actions before these severe attacks may be involved in the realization of these severe attacks, and so on.